My name is Bongani Mabuza. I'm coming from Radar and Electronic Warfare here at CSIR. And I also have a nickname. You can call me BCM if Bongani is too long for you. Today I will be telling you about a few things. I'm not an expert, so whatever you take from me today, please don't hold me accountable, okay? So anything that you absorb, you are doing it at your own risk, right? So when you go and share information with your friends at home, they're what you have learned today, don't mention Bongani, right? Otherwise I'll be in trouble. But they said we need to ask questions. So can I ask a few questions? I'm not good in asking questions, so I'll try. Okay, they said this area has explosives. So can I ask you, do you want to be blown away or do you want to be blown here? Someone say blown away, someone say blown here. Some of you? Okay, maybe the question was difficult. Let me try another question. Do you want me to tell you everything or would you like me to tell you anything? Come on, that's also tricky. Okay, you know what? I'm going to try one more. If I fail here, I don't know what to do. Can I ask you a question?
Go ahead.
Where are you? Where are you? Where are you? CSIR. Where is CSIR? It's in Pretoria. Where is Pretoria? It's in Gauteng. Where is Gauteng? But where is South Africa? Come on, guys. Where is Africa? It's on Earth? Where is Earth? It's in the planet? No, I don't know if I should stop or what. Where is planet? You want me to continue?
Yes.
Okay. This is really where you are, guys, in Pretoria. And as you can see, Pretoria, as you have mentioned correctly, we have planets, which is within the solar system. Solar system lies in our Milky Way galaxy. Galaxy is somewhere in other galaxies, and those galaxies are somewhere within the universe. And yeah, we can never stop. And that's how also information and knowledge happens. Albert Einstein, amongst others, they've generated knowledge to a certain level. They generated knowledge in CSIR. Other people took that knowledge to where? To Pretoria, outside Pretoria. Some of those people took that knowledge to what? To Africa, all over the world. That is why today we can share the information all over. But what happens to information? It grows and grows and grows over time. Even us as scientists, we're going to do certain things, but we have to stop somewhere. Like in a relay race, okay? At some point, we will be giving you a stick, and you need to take it to the next person who will be following you. Okay?
Yes.
So since you have an idea as you are, let me give you an idea as who I am. Are you interested to know?
Yes.
Okay. I've mentioned that my name is Bongani Mabuza. As Pete has mentioned, I also come from a different background where, certain things were done in Zulu, not necessarily in Spedi. But I studied in an environment, do you know Mutse? That area that was previously Mpumalanga, now it's also Limpopo. That's where I come from, if you know about it. Not far from Kroblastan. So I went to St. Joseph Comprehensive School, then I came to University of Pretoria to pursue my studies, up until I got my master's degree in microelectronics. And while I was there, I also started lecturing and teaching people at the University of Pretoria until I realized that, you know what, I don't need just to know about books only. Let me also see how are people doing things hands-on. Then I went to work at Nokia Siemens Networks, where I was doing what? Charging and billing applications. To give you an idea, those applications we were building are the ones where you buy power hour, those friends and family, those 3 minutes when you buy airtime, you get free data. Those are the type of applications we were building at Nokia Siemens Networks. Then I went to work at Denel, of which Denel basically I was working in missile technologies, a different type of a bomb than what people are doing here. The only thing I can mention that about missiles is that they are very harmless devices, okay? Especially if you don't use them, okay? So if you keep them there, they are harmless. Once you start using them, I don't know what usually happens. So I've never witnessed that in my life. So hopefully you guys will be there to do so. Then I went to SKA. The previous image as to where you are, that's what SKA tries to do. They try to probe into deep space. They try to understand galaxies. They try to understand the universe. What is the relationship between stars, amongst other things? So I had an opportunity to go work with the people at SKA in technologies related to what? To radio astronomy. I'm not an radio astronomy person. I was building an instrument for them. Okay? Like the people who build cameras, there's also a cameraman. A cameraman does not necessarily know how to build a camera, but he knows how to use it. So there at SKA, I was helping them to build an instrument, but I wasn't necessarily the person who was using the instrument to do interesting things. So I ended up here at CSIR, where I'm actually in the radar and the EW environment. It's a very long story, okay? But I'm still young, 24. So. Okay, that's the last time I stopped counting. What's happening now, okay? So, since you have an idea about me, one of the things that I would like to mention, okay, is that one of my objectives basically is to continually, and Pete also said this before, to continually grow my skills and capabilities, okay? Why? So that I can be in a better position to try and solve some of the problems and challenges that we are having here in this world. Okay. But one thing I can tell you is that the problems and challenges that we are having cannot be solved by one person. Okay. They are so much. So I will solve some of them, and I will definitely leave some for you guys, right? Are you happy with that? So yeah. That is why they say 2 hands are better than 1, right? What does that mean? Does that mean that's why I don't have 1 hand, I have 2? I'll leave you to think about that one. So, what will I tell you about? What will I talk about today is the following. I'll give you some basics of radar, some basics of EW, and I'll also give you some examples in terms of applications as how we use our technologies. Then I will just wrap up with some of the challenges and opportunities, of which I think even when you come to join CSR in future, you will still find those problems and opportunities in existence. Time is always limited, so sometimes you try to fit everything into small time. Sometimes it does happen, but sometimes things don't work quite so well, okay? So I hope I will be more successful than the guy who's trying his best there to squeeze everything into this time slot that have been allocated to you. So, radar basics. Does anyone have an idea what is a radar? Has anyone seen a radar? No? Okay. I'll give you some examples. It's a very simple instrument, okay? Very simple. It works in very basic principles. Principles that you can relate with. Let me ask you a question. Do you know a tennis ball? Yes. If you stand straight in front of the wall and you throw the tennis ball to the wall, what will happen to the tennis ball? It will bounce back where? Where will it go? It will come back to you. Okay? If you stand on the side of the wall, you throw the tennis ball, will it still come back to you? It won't come back to you, right? Radar works in the same principle. It sends electromagnetic waves into space. Okay? If there's no object, those waves will continue going. If you have an object like a wall or an aircraft, those waves will hit that object, and some of them will reflect back in different directions. Some of those will come back to what? To the radar itself. Okay? That's the basic principles of a radar. It sends electromagnetic waves, they go into space. There are some objects there. When it hits those objects, some of the signal will come back, some of it will go away, just like a tennis ball. If you stand in front of the wall, it comes to you. If you stand on the side, it goes elsewhere. Okay? Same thing applies in radar. Still on the tennis ball, if you take a tennis ball, you guys are doing physics, some of you, right? If I take a tennis ball, I throw it up and it comes back to me. In physics, they will tell you the time the ball takes to go up is the same as the time it takes to what? To come back to you. The time that the wave takes to go to the aircraft is the same as the time that the wave will take to come back to the radar. You see how simple radar is? And that is how we determine what? The distance of an object. Because if we know the time that the signal will go and come back to us, remember we don't know where the object is, right? We can only know the time, the total time it took for the signal to go and come back. So how do we know the time that it takes to go to the aircraft? Remember, the time it takes to go up is the same as the time it takes to come down. So if you have the total time, to get the time to go to the object, well, what do? You divide by 2. That's what we do here, and they call us scientists just to do that. Isn't that interesting? So that's how a radar actually works. The time it takes for an object to go and to come back, you measure that one, you divide by 2, and it tells you about what? The distance. But there's one more thing. Electromagnetic waves travel at a what? At a certain speed. In this case, they travel at the speed of what? Of the light. And in physics, you know, if you have the speed of it, that's the speed of the light. If you can measure the time, you can use those two things to calculate what? Distance, right? So we can determine the distance of an aircraft by using a radar system. In physics, you learn another thing. They tell you what? In physics, they say to calculate a speed of an object, you basically need what? A change in distance over what? Change in time. Okay. So radar can also calculate the speed of what? Of an object. But there's a trick. If I have 1 point, can I determine the speed using 1 point? No, I need 2 points because I need a change in distance. I need 2 time instances because I need a change in time. So how does a radar determine the speed of an object? It sends a signal, receive it back, calculate one distance, 1 time. It sends it again, calculate the distance and the time. So now we have more than 1 point. We can have 10 points, we can have whatever number of points. And using that basic principle, we can determine the speed of an aircraft. Isn't that amazing? The same physics that you study at school. We don't do anything tricky here, okay? We just apply what you learn at school. And that is the basic operational of what? Of a radar system. Obviously, you can use a radar system for different applications. You can use radar for detection and search. For example, in the airports, a radar is used to make sure that you can control the traffic of aircraft, okay? You can use radar in terms of tracking and fire control. For example, if people fire missiles and things like that, or you want to shoot down an aircraft that come and invade your country, you can use a radar for that purpose. You can use radar for imaging. Imaging, in this case, it means that I can use a radar to determine the shape of an aircraft without knowing it. While the aircraft is in space, I can send the signals. If the signals come back, I process them until it gives me an idea about the shape of the object that is out there in space. That is what we mean by imaging. Okay. And I've mentioned already, we can determine speed, you can identify the target, what type of a target. Is it a human being? Is it a boat? Is it an aircraft? Or any other object? So by using just the signal that is reflected back, we can determine a number of things using what? A radar system. And obviously, there is maths that we have to deal with, right? How many of you like maths? Why is maths such a powerful thing? Does anyone have any idea? There's a saying that any physical thing that is out there can be described just using mathematical equations. Even human behavior, your behavior can be described using some equations. Radar system can be described using what? Using equations. How an aircraft flies in the air can be described using what? Using equations. And this is one of the important things, that if you have mathematical skills, it enables you to solve a lot of the problems. That's why previously the government even had mathematics so that we can have an option of not doing mathematics. But they realized that, without maths you can't do that much. That's why they introduced mathematics literacy. Because each and every single one of us need mathematics. There's seldom much you can do without having a mathematical background or knowledge. So I'm not going to explain these equations for you, but just to give you an idea, that situation that I explained to you about radar can be described in simple equations that we can go analyze, project things, and solve more problems out there. Okay, now I'm just going to tell you about the second part, of which basically this is about the electronic warfare. Okay, so electronic warfare is a much broader field than just talking about radar. Okay, electronic warfare, sometimes we call it's about situation awareness, it's about protection, and sometimes it can be about an attack. But the whole scenario of electronic warfare is that each and every country needs to get to the point where you can protect your borders. Let it be on land, let it be on ocean, let it be in space. Okay? And sometimes the radar system alone does not help you to do that. A good example is underwater. You cannot use a radar in that instance. So sometimes electronic warfare has multiple sensors. Even communication is part of electronic warfare instrument. To give you an idea, previous in some of the world wars that have happened, one of the things that people used to do in electronic warfare is to shut down the communication system. So people couldn't communicate. So you go into war, you don't even know where your other people, your fellows are. You can't even tell them that, hey, these guys are coming from the south or from the east. Why? Because they killed the whole communication system. So that is part of electronic warfare. We call it communication intelligence. There's also signal intelligence. Even in radar, people can shut down my radar system. Remember, a radar does what? It sends a signal and it must receive it back. So electronic warfare can do what? They can send more signals to me. So now when I get a signal, I don't only get my signal, I also get all these other signals that I don't know, and I end up being what? Confused. And once I'm confused, I cannot even tell where is the aircraft, how fast is it moving, what type of an aircraft it is. All of those things are part of what the electronic warfare. And it involves multiple domains and technologies, as you can see. The type of aircraft you use, that is why passenger aircraft and fighter aircraft are different. Okay, so all of those things are part of what electronic warfare is about. And I have an example, I think on the next page. Let me give you a scenario. For example, a typical electronic warfare scenario. Here, on this case, the example is on USA. Say in South Africa, we want to go and attack USA. So we started number one, we want to launch what? A missile. Okay. But USA, you know what? If you are in trouble or you are not in good state with other people, we are always monitoring. And that's what electronic warfare is about. You don't just check whether you are in good position at that point in time. There's always sensors that are checking around South Africa what is happening. If aircraft is not supposed to come to South Africa, we'll know about it. And we'll start to communicate with them. If they don't listen to us, then our fighter aircraft will try and escort that person out. If they are not responding, we take them down. So it's not an exercise that we do once off. We have to monitor your environment all the time, and that's what electronic warfare is about. So even if we can try to launch a missile, we can find that we have a radar that can detect that, okay, a missile has been launched. And other than that, you can have a satellite, which is another form of sensor. These days, you also use satellite technologies to monitor when people are launching missiles, when people are launching nuclear bombs, amongst other things. And using that, you can also have other support equipment like your ground-based radar. You can have your sea-based radar that is also monitoring. Okay, you can even have what infrared sensors. You can have lasers that you can use as part of your sensors to support your whole EW scenario. So I won't go into a lot of details, but one of the things you want to do is that if people are firing a bomb at you, you want to be in a position to either send another one so that it intercepts it. We call it intercept. Because if it comes to you, it can destroy you. Okay. So this is another typical scenario that tells you that what electronic warfare is about. It's about being aware of the situation around your country and having systems that can protect you so that if someone tries to come and invade you or do something to attack you, you are in a position that you can protect the people of your country, amongst other things. To give you an example, some of the world wars, what they used to do is to destroy your power line system. They know if you destroy ESCOM, the country will be in trouble. If you destroy things like your Vodacom, your telecoms, people won't be able to communicate. If you destroy bridges, amongst other things, people won't be able to maneuver between different cities. They will trap into one area. And all of those things are part of electronic warfare. So it's a much broader domain, and it involves, amongst other things, that you must account for. Okay, to give you an example of some of the applications that we are essentially having, I've mentioned air traffic control to ensure that actually we can fly safely and that we can also monitor our airspace. One of the good examples that we have these days also is in terms of rhino poaching. There's also an online video that we are having. So we are also using radar systems to assist people at Kruger National Park so that we can protect our animals and those people who are trying to do poaching. So if you can go online and just search around Kruger National Park and CSIR, you'll find one of the interesting videos which basically tells you amongst all the things that we have assisted them using radar technologies and amongst other technologies from optronics point of view that actually enables them to protect our systems. Another interesting one that I like to show people as an example is what we call audio radar. In this case, it doesn't work in microwave, it essentially works in sound wave. Why I like this example is because something you can do at home. By just having your laptop, having your speaker, having your microphone, we can illustrate radar concept. You can set it up at home, put it on the table, send signals, sound waves, they go out. After that, they reflect back, they can tell you how far this one is. If you have someone walking around, it can tell you the speed at which they are walking. Okay, just a simple system that can help you to illustrate some of the radar concepts. One of the things in engineering these days is that back then people used to build systems. When the system doesn't work, it breaks. You waste a lot of money. So these days is that you can even make an aircraft on your computer. You can make an aircraft fly on your computer using simulators. It can help you to save money. At the same time, it can help you to achieve a lot. You can simulate a lot of things. So modeling is one of the critical things that we use these days as part of solving our problem without wasting a lot of money while we come up with solutions. Okay, I will run over this one. I'll go to this slide, which I think is interesting. When I saw it, I was not happy. And the reason that I was not happy, because it tells us very important information. It tells us that, I'll focus on the black African, okay, because I don't have time to look at all the things, but it tells you that more than 50% of black African people do not have matric. It tells you that only about 28% have matric, and it tells you that about 5% are graduates, and more than just 10% have other qualifications, not just graduates. Maybe that's your master's and PhD. But the values are shocking. It means people who have more than just a matric are just 15% out of 100%. That is not good figure for anyone who's sitting here, for any of us. And that is why we continue to try to reach out to you, because we like those numbers to change. Because if we need to solve some of the challenges and the problems that we are having, that will not help. If you understand that South African population is dominated by that top list, which is the black people, and only just 15% of them has more than matric who are in the working environment, it's very shocking. And we hope for you guys that you will be able to pursue your studies so that we start changing these numbers. Like I said, the problems that we have are more than just 1% can handle. And we need more of you to come here at CSIR amongst other institutions to help us solve these problems. Okay. And I do understand that sometimes, as you try to solve certain problems, they will always look bigger than what you think you can do. But remember, the fact that we have bigger problems and challenges does not make it impossible for you to solve them. So please, let us work together to solve our problems. And the nice thing about the quote at the bottom that it says, as we let our own light shine, we unconsciously give other people permission to do the same. That is why we are here today, because we went through certain things, and we want to enlighten you based on the route and the path that we have taken, so that we can make your path also shine as we continue to pursue our goals and dreams, so that you too can achieve yours. Thank you.
Any questions? Any questions, guys? I mean, the morning to say that we are going to how did you do my poor?
Says it's number 9 and 20, right? And generally, the failures are 100 times numerous than the success, but yet they are left uncommitted. So, what were the trials and failures that you once faced on your youth time, like high school time, during that time?
That is an important thing you've just asked. She said, sometimes along the way we have failures, and that sometimes the number of failures are far more than the number of successes that you achieve. You remind me of this person, I don't know by his exact name, the one who tried to make a light bulb. He said, I didn't fail 1,000 times or 10,000 times. I just found so many ways that don't work. So he never regarded it as a failure. And I sometimes tell people that, you know what, in life you have two options. It's either you succeed or you learn. So failure does not succeed. The only time you fail, that's when you don't learn from what didn't go right. That's when you don't learn from what didn't happen. Yes, I had my own successes and I had my own failures along the way. And one of the things, let me tell you something. When I grew up with my uncle who had taxis, who was fixing his own taxis, and I was inspired by that. And along the way, I was like, you know what, I'm going to do mechanical engineering. I went to a technical school where before I chose, I had an option of doing mechanical, I had an option of doing electronics, woodworking, and metal work. But you know what? I realized that mechanical engineering was not my thing. I was not succeeding in that area. Then that's where I started falling in love with electronics. And since then, I never looked back, up until today, up until I did my master's degree in electronic platform. Same thing with families. Remember, success and failure is not about what you do at school. As a human being, your life needs to be balanced. You have the social aspect, you have the educational aspect, and you have relationships with other people. Even in relationships, I have those that have failed. And each time I also learn from them. That you know what? If you do not want WhatsApp enough, if you do not say I love you enough, people are not going to be with you anymore. We have families who have high expectations. Sometimes the expectations you put under pressure that you cannot even focus on yourself. And by the time you start focusing on them, it's part of your failure because you disconnect from them. So yes, there has been, if you look at the whole aspect of life. And what I like is what you have mentioned is that let us not see failure as a random thing. Failure is part of the process. But again, failure is about learning. It gives you an opportunity to learn. Because so many often, as an engineer, we learn more if we try to build systems and they don't work first time around. Because if they don't work, we start doing what? We start asking questions. And earlier on you were told that being innovative, being creative is about asking questions. And sometimes some of the failures or challenges that you confront, they put you in a position whereby you start asking questions. You start challenging traditional ways, because traditional ways don't help you to reach to the goals that you want. You start being radical. Not economic radical, but amongst other radical things that you need to do. But yeah, it's a good one. I can go with the list, but yeah, you need to have the ability to stand up again and have a bigger goal and vision. If you have a goal, whatever happens along the way, you will always be focused. One part may not work, but remember, there's a 10,000 parts that can take you there. Thank you.